Alright, this video is coming to you on a Monday. Hopefully you don't have a case of the Mondays. This is going to cover the Ready for More, which is going to tie up the end of the lesson that we were working on. Before I do that though, I'm going to skip over to the something to talk about. And it says, which table or tables represent a quadratic function? Explain your answer. You better have an explanation on this. The biggest takeaway from this is we went back and we looked and we said, hey, how do you, from a table, how do you determine whether something is linear, quadratic, or exponential? So from this, it's saying which table is exponential. Well, here's the gist of this if you weren't here. We'll just cut to the chase because that way you don't have to stop and think too much. If we do a first difference here, okay, we're going to do first and second differences. If we do a first difference, what do we get? We get plus 2, plus 4, plus 8, plus 16. If we do a second difference, we get plus 2, plus 4, or some people noticed it was times 2, times 2, times 2, right? This actually, the addition actually keeps repeating itself, but if we go to addition, a first difference, and a second multiple, we've never had a table where we've had a first difference and second multiple. So this, I don't even know what type of function this is. I know it's not linear, I know it's quadratic. A is not going to be a choice. B, what is going on with table B? Table B, a first difference is 2 to 3 is plus 1, 3 to 6 is plus 3, 6 to 11 is plus 5, and we have plus 7. A second difference is going to be plus 2, plus 2, plus 2. This is your quadratic, or this one is quadratic at least, right? And then if we go down to C, how do I go from negative 5 to negative 2? Think about it, negative 5 to negative 2, that's a plus 3. Negative 2 to positive 1 is a plus 3. 1 to 4 is plus 3, so you can see what's happening here. The first difference is all of plus 3, so that's linear. But it wants to know which one is quadratic. So B is your answer choice, all right? B is quadratic, and you need to explain. So the answer is B, all right? But explain. So stop the video for a second, and as best you can in a complete sentence, explain. All right, now we come back up here, and it says, ready for more. Using the same sequence of figures, model the relationship between the perimeter and the figure number. We're going to use this table right here. Well, here's the figure number. It's 1, 2, 3, 4. And it says the figure number and perimeter. Alright, so what is the perimeter of the figures in the previous example? Well, figure number 1. What is the perimeter? How do you find the perimeter? Amazing, some people can't figure it out. You add all the sides. Come on, we've known that for a long time. Perimeter in figure 4. Pause and find the perimeter for all of the other remaining 3 figures. Right? Pause it. You should get 8, 12, and 24 when you paused it. So we will come back down here and we will say, 4, 8, 12. 4, 8, 12, sorry, not 24, 16. I said 24. That's a mistake. It's been a long day. That is not 24. Scratch that. That is 16. So now, when we look at this, it wants me to write an explicit equation recursive. Like, I don't know what the data is telling me. The previous example, all the table up there, it was quadratic. How did we determine that? We had a second difference, remember? Go back up here. Look at it. It had second differences. It was all 1, 1, 1, 1, 1, 1, 1, 1. All right? That was a second difference. But here, what do I do to 4 to get to 8? Plus 4. I could times 2, but 8 times 2 is 16, not 12. So that's plus 4, plus 4. This is a common first difference. So the common first difference means it's going to be a linear. An explicit linear equation is f of x equals my starting value, 4, plus my rate of change, 4 times x minus 1. There's my explicit equation. Go back to page 3 and 4 and look at that if you need to. I'm almost positive it was page 3 and 4. In fact, I'll double check. Right? Because this is something you need to make sure that you understand. I'm sorry, 4 and 5, not 3 and 4. 4 and 5, back here. Now, your recursive equation. So I'm going to look at recursive, and that's going to look like this. It could look. I'll write it differently here, but f of 1 is equal to my beginning value 4, which is what I needed for my explicit equation anyway, and then f of x is equal to f of x minus 1, and if you go in here, it tells you the common difference, so plus 4. There's your recursive equation. Now another way you might see this, I wouldn't even go there, okay? It's a video most of you aren't going to watch anyway. I'll try and stress that tomorrow before we take the quiz. So now, some takeaways from a quadratic function. In a table, it's a second common difference. Okay? The graph is U-shaped, or it's a parabola. The recursive equation, we're going to base this recursive equation off of our information that we did in the quadratic function, which the recursive equation for that should be f of x. And here's where I'm going to write this different. F of x is equal to f of x minus 1 plus x. That's straight out of question number 3 in the notes. If you go back, it's straight out of this question right here. Okay? If you need trouble with this, ask. And then we need a comma over here, and we need f of 1, which what was the value in our first figure? It was 1. So f of 1 is 1. So here's how it's kind of written differently. So there's a couple of differences right there. You can write f of 1 is 4. I wrote it first and then wrote the other second. Here I wrote, I did it backwards. So what? The next, what this means is previous plus next term. Okay? Still trying to figure out where that comes in, but that's where that's at in the notes. And then now, how about my explicit equation for this? The explicit equation for, again, go back to number 3. That was f of x is equal to the 1/2 n times the n plus 1, where we related everything to area, and this was my length, this was my width, and that's how I find area. But if you notice, if you remember, we had 3 boxes, we had 2 boxes, we had 1. It kind of sort of looked like we were only dealing with half of the area of a square. And that's where the kind of sort of where the half came from. Lesson summary. Quadratics have how many differences? Quadratics have how many differences? That's my lesson summary. Fill that one in. And make sure you get your work in on time. No late assignments.